In this experiment, we'll be showing you how to turn an ordinary flask into a beautiful silver mirror. Chemical concepts shown in this experiment will include oxidation-reduction reactions, aldehyde reactivity, and Toland's test. Let's start off by talking about oxidation-reduction reactions. An oxidation-reduction reaction is a type of chemical reaction that involves a transfer of electron between two species. An example of this is the chemical reaction between zinc and a copper 2+ ion. The zinc is oxidized in this reaction, meaning that 2 electrons were lost, forming the ion of zinc 2+, while the copper 2+ ion was reduced and gained 2 electrons, forming copper. Aldehyde reactivity and Toland's test. Toland's reagent is a chemical reagent used to determine the presence of an aldehyde or alpha-hydroxy ketone functional group. In this example, when a Toland's reagent compound is poured into a solution containing no aldehyde groups, the solution will remain clear, showing negative results to Toland's test. But if the compound is poured into a solution that does contain an aldehyde group, the solution will precipitate, and in this experiment, that is what causes the silver to deposit on the sides of the flask. Now let's take these concepts and apply them to our experiment. As you can see, we have the chemical formula for the reaction between dextrose and the silver diamine ion, which yields metallic silver. This will be deposited on the walls of the flask in the form of a reflective mirror. In this reaction, the silver diamine ion acts as the oxidizing agent, which oxidizes the aldehyde functional group CHO of dextrose, a reducing sugar, to a carboxylate ion, COO negative. As this oxidation occurs, silver is reduced from the +1 oxidation state to metallic silver. The silver diamine ion also acts as the Toland's reagent in this experiment. Because dextrose contains an aldehyde group, it produces a positive Toland's test. Evidence of this is that it reduced the ion to metallic silver, and because of this, dextrose is also called a reducing sugar.
Tell me when to stop.
For this experiment, you'll need a graduated cylinder, a Florence flask, a stopper, a graduated pipette, a stirring rod, and a large beaker of water. Chemical ingredients include 30 milliliters of 0.1 molar silver nitrate, 15 milliliters of 0.8 molar potassium hydroxide, 10 milliliters of 0.25 dextrose, and 2 to 4 milliliters of ammonium hydroxide. These are some calculations done to figure out how many grams of each ingredient was needed in 100 milliliters of DI water. This would be a good time to pause the video to gather all of your ingredients and equipment. Finally, before we begin, there are some safety precautions to take note of before conducting the experiment. Silver nitrate, potassium hydroxide, and ammonium hydroxide are all some type of eye, skin, or respiratory irritant. Do not ingest and avoid contact with eyes when using any of these chemicals. To ensure this, wear chemical-resistant gloves and goggles, and after this experiment is conducted, make sure to immediately dispose of the unreacted mixture, as explosive compounds may form if allowed to heat and stand. Now let's begin the experiment. Make sure that gloves and goggles have been put on before handling chemicals.
And then hold
Prepare
up the
a
water,
large
the big
1,000
beaker
milliliter
water.
beaker full of water for disposal.
And then put it back down. Okay, and then you can
Add 10 milliliters of the 0.25 molar dextrose solution to a clean 250 milliliter Florence flask and add the stopper on and place it on the side. Then add 30 milliliters of 0.1 molar silver nitrate solution to a 150 milliliter beaker.
Wait,
While
pause.
stirring, add concentrated ammonium hydroxide dropwise to the silver nitrate solution in the beaker until a precipitate forms. Continue adding ammonium hydroxide dropwise while swirling until the silver diamond ionic complex formed and the solution just becomes clear in color.
So it looks like spooky. So it lights flicker a little. Okay, wait. It's not working. It says concentrated ammonium hydroxide dropwise silver nitrate beaker until gray black silver forming. Yeah, but there's no. How's it gonna become gray also?
Then add 15 milliliters of the 0.8 molar potassium hydroxide solution to the beaker. The silver hydroxide solid usually precipitates again, so add concentrated ammonium hydroxide dropwise while swirling until the solution just clears.
This is like what you see in like cartoons and stuff. So it becomes clear.
Pour the contents of the beaker into the 250 milliliter flask with the dextrose already in it. Insert a stopper or cap and swirl gently so the liquid contacts the entire inner surface of the flask, including the neck. Continue to swirl and within 5 minutes the entire flask will be coated with a silver mirror surface.
Okay, then you can just put it by the neck probably and then swirl. Or by the neck. We're not even thinking about it.
Here you'll begin to see the mirror forming. Continue to swirl until a full reflective mirror has been formed on the side of the flask.
I know, but you like mixed it out super fast. It was like it's like silver. It's like silver nitrate. Silver from solution. Yeah. Silver. Yeah. Yeah. I can stop and just we're gonna like just sit slowly and like turn like all the
When finished with the experiment, be sure to properly dispose of the solution inside of the flask and clean the flask out with DI water.
I don't think you have to get this whole part.
Yeah, you don't have to.